Motion of a freely falling body. Objectives. Explain Galileo's theory of motion and Newton's laws of motion. Apply all the equation for motion of an object in free fall. To solve problems on free falling bodies and the acceleration of gravity. Galileo. The remarkable observation that all free falling objects fall at the same rate was first proposed by Galileo, nearly 400 years ago. Galileo conducted experiments using a ball on an inclined plane to determine the relationship between the time and distance traveled. Galileo. He found that the distance depended on the square of the time and that the velocity increased as the ball moved down the incline. The relationship was the same regardless of the mass of the ball used in the experiment. Galileo. The story that Galileo demonstrated his findings by dropping 2 cannonballs off the Leaning Tower of Pisa is just a legend. However, if the experiment had been attempted, he would have observed that one ball hit before the other. Introduction to free fall. A free-falling object is an object which is falling under the sole influence of gravity. That is to say that any object which is moving and being acted upon only by the force of gravity is said to be in a state of free fall. This definition of free fall leads to 2 important characteristics about a free-falling object. Free-falling objects do not encounter air resistance. All free-falling objects, on Earth, accelerate downwards at a rate of 9.8 meters per second or 32 feet per second/s. Freely falling body. The acceleration of freely falling body is so important that physicists called it acceleration due to gravity. Denoted by letter G, which is equivalent to 32 feet/sec2 or 9.8 meters/sec2. Meaning in the first second, a falling body accelerates from a stationary position to a velocity of 9.8 meters/sec2. After 2 seconds, the velocity is doubled to 19.6 meters/sec2. After 3 seconds it triples to 29.4 meters/sec2. Freely falling body. Since accelerating objects are constantly changing their velocity, you can say that the distance traveled divided by the time taken to travel that distance is not a constant value. A falling object, for instance, usually accelerates as it falls. The fact that the distance which the object travels every interval of time is increasing is a sure sign that the ball is speeding up as it falls downward, a simple rule to bear in mind is that all objects, regardless of their mass, experience the same acceleration when in a state of free fall. When the only force is gravity, the acceleration is the same value for all objects. On Earth, this acceleration value is 9.8 meters per second, that it is given a special name, the acceleration of gravity, and a special symbol, g. Newton. Newton's first law, the law of interaction, states that for every action there is an equal and opposite reaction. Newton's second law, the law of acceleration, states that the acceleration of an object is directly related to the net force and inversely related to its mass. Newton's law of acceleration. F net equals ma. A equals F/m. Acceleration depends upon 2 factors, force and mass. The 10-kilogram elephant obviously has more mass, or inertia. This increased mass has an inverse effect upon the elephant's acceleration. And thus, the direct effect of greater force on the 10-kilogram elephant is offset by the inverse effect of the greater mass of the 10-kilogram elephant, and so each object accelerates at the same rate, approximately 10 meters per second. 1 Newton is defined as the amount of force required to give a 1 kilogram mass an acceleration of 1 meter per second. Complete the table: net force, N, mass, kg, acceleration, meter per second, 1, 10, 2, 2, 20, 3, 4, 4, 5, 5 meters per second, 10 meters per second, 5 meters per second. 10. 1. Free fall and the acceleration of gravity. Free-falling objects are in a state of acceleration. The velocity of a free-falling object is changing by approximately 10 meters per second every second. If dropped from a position of rest, the object will be traveling approximately 10 meters per second at the end of the first second, approximately 20 meters per second at the end of the second, approximately 30 meters per second at the end of the third second, etc. Free fall and the acceleration of gravity. The velocity of a free-falling object which has been dropped from a position of rest is dependent upon the time for which it has fallen. The formula for determining the velocity of a falling object after a time of t seconds is Vf equals gt, where g is the acceleration of gravity. An approximate value for g on Earth is 10 meters per second, more exactly, its value is 9.8 meters per second. Example calculations for velocity. Calculate the velocity of a free-falling object after 6 and 8 seconds. Vf equals gt. Solution. At t equals 6s. Vf equals 10 meters slash s2, 6s. Equals 60 meters per second. At t equals 8s. Vf equals 10 meters slash s2, 8s. Equals 80 meters per second. Velocity of freely falling body. If you were to observe the motion of a free-falling object, you would notice that the object averages a velocity of 5 meters per second in the first second, 15 meters per second in the second, 25 meters per second in the third second, 35 meters per second in the fourth second, etc. Our free-falling object would be accelerating at a constant rate. Distance. The distance which a free-falling object has fallen from a position of rest is also dependent upon the time of fall. This distance can be computed by use of a formula. The distance fallen after a time of t seconds is given by the formula d equals half a gram t2, where g is the acceleration of gravity. Example calculations for distance. At t equals 1s, d equals 0.510 meters slash s2, 1 s2 equals 5 meters. At t equals 2s, d equals 0.510 meters slash s2, 2s2 equals 20 meters. At t equals 5s, d equals 0.510 meters slash s2, 5s2 equals 125 meters. Calculate the distance fallen by a free-falling object after 1, 2 and 5 seconds. D equals 0.5 gt2. Distance. Given these average velocity values during each consecutive 1-second time interval, the object falls 5 meters in the first second, 15 meters in the second, for a total distance of 20 meters, 25 meters in the third second, for a total distance of 45 meters, 35 meters in the fourth second, for a total distance of 80 meters. 0 to 1s 5 meters per second, 5 meters, 1 to 2s 15 meters per second, 15 meters, 20 meters, 2 to 3s 25 meters per second, 25 meters, 45 meters. D equals 0.5 10 grams slash s2 once 2. Time interval. Average velocity during time interval. Distance traveled during time interval. Total distance traveled from 0s to end of time interval. 0 to 1s. 5 meters per second. 5 meters. 1 to 2s. 15 meters per second. 15 meters. 20 meters. 2 to 3s. 25 meters per second. 25 meters. 45 meters. 3 to 4s. 35 meters per second. 35 meters. 80 meters. V equals 0.510 meters slash S2 ones. D equals 20 minus 5. V equals 0.5 gt. D equals dtd. D equals 0.5 gt2. The table illustrates that a free-falling object which is accelerating at a constant rate will cover different distances in each consecutive second. Further analysis of the first and last columns of the table above reveal that there is a square relationship between the total distance traveled and the time of travel for an object starting from rest and moving with a constant acceleration. For objects with a constant acceleration, the distance of travel is directly proportional to the square of the time of travel. Equation for motion of an object in free fall. Sample problem. A coin was dropped from the top of the LTA building with a height of 727 feet. If there is no air resistance, how fast, foot per second, will the coin be moving when it hits the ground? 215.68 feet per second. Solution A. Problem 1. A marble is dropped from a bridge and strikes the water in 5 seconds. Calculate the speed with which it strikes and the height of the bridge. Vf equals 49 meters per second, d equals 122.5 meters. Solution 1. P2. A feather is dropped on the moon from a height of 1.40 meters. The acceleration of gravity on the moon is 1.67 meters slash S2. Determine the time for the feather to fall to the surface of the moon. T equals 1.29 seconds. S2. P3. The observation deck of the World Trade Center is 420 meters above the street. Determine the time required for a penny to free fall from the deck to the street below. T equals 9.26 seconds. S3. P4. With what speed in miles per hour, 1 meter per second equals 2.23 miles per hour, must an object be thrown to reach a height of 91.5 meters, equivalent to 1 football field? Assume negligible air resistance. V equals 94.4 miles per hour. P4. P5. A 10 kilograms block being held at rest above the ground is released. The block begins to fall under only the effect of gravity. At the instant that the block is 2.0 meters above the ground, the speed of the block is 2.5 meters per second. The block was initially released at a height of how many meters? D equals 2.3 meters. S5. Assignment 1. Miguel drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. 2. Brandy throws his mother's crystal vase vertically upwards with an initial velocity of 26.2 meters per second. Determine the height to which the vase will rise above its initial height. Assignment 3. A kangaroo is capable of jumping to a height of 2.62 meters. Determine the takeoff speed of the kangaroo. 4. A stone is dropped into a deep well and is heard to hit the water 3.41 s after being dropped. Determine the depth of the well. 5. Ronald McDonald is riding an air balloon on his way to Subic. If Ronald free falls for 2.6 seconds, what will be his final velocity and how far will he fall? Prepare for an exam next meeting. End of presentation. A bowling ball falls freely, near the surface of the earth, from rest. A bowling ball falls freely, near the surface of the earth, from rest. How far does it fall in 4 seconds, and how fast will it be going at that time? The ball's average speed for the first 4 seconds is the average of 0 meters per second and 40 meters per second, its starting and ending speeds, and distance equals average speed times time. So the object will have fallen 80 meters, and its speed will be 40 meters per second. The position of a free-falling body, neglect air resistance, under the influence of gravity can be represented by the function where g is the acceleration due to gravity, on Earth, and s0 and v0 are the initial height and velocity of the object, when. Example, falling object problem, a ball is thrown vertically upward from the ground with an initial velocity of 160 feet per second. A. When will it hit the ground? Solution. Since when we need this is precisely when or and thus the ball will hit the ground in 10 seconds. With and we need. This illustrates that a free-falling object which is accelerating at a constant rate will cover different distances in each consecutive second. Further analysis of the first and last columns of the table above reveal that there is a square relationship between the total distance traveled and the time of travel for an object starting from rest and moving with a constant acceleration. For objects with a constant acceleration, the distance of travel is directly proportional to the square of the time of travel. Time interval. Average velocity during time interval. Distance traveled during time interval. Total distance traveled from 0s to end of time interval. 0 to 1s. 5 meters per second. 5 meters. 1 to 2s. 15 meters per second. 15 meters. 20 meters. 2 to 3. 25 meters per second. 25 meters. 45 meters. 3 to 4s. 35 meters per second. 35 meters. 80 meters. As such, if an object travels for twice the time, it will cover 4 times, 22, the distance. The total distance traveled after 2 seconds is 4 times the total distance traveled after 1 second. If an object travels for 3 times the time, then it will cover 9 times, 32, the distance. The distance traveled after 3 seconds is 9 times the distance traveled after 1 second. Finally, if an object travels for 4 times the time, then it will cover 16 times, 42, the distance. The distance traveled after 4 seconds is 16 times the distance traveled after 1 second.